In the previous example, it showed how to convert from a given sample value to the corresponding percentile. There are different methods for the reverse procedure for converting a given percentile to the corresponding value in the data set. The procedure we used is summarized in the figure, which is going to be here below, which uses the following notation. N represents the total values in the data set. K represents the percentile being used. For example, for the 25th percentile, K would equal 25. Capital L is the locator that gives the position of a value. So for example, for the 12th value in the sorted list, L would equal 12. And then P, capital P subscript K, this is the kth percentile. So for example, P subscript 25 is the 25th percentile. So let's see the procedure for converting a percentile to a data value. First thing is to start. You sort the data, arrange the data in order of lowest to highest. Then you're going to compute the following. You're going to say L, which is equal to the value of K divided by 100 times N, where N is equal to the number of values and K is equal to the percentile in question. Now, if the value of L is a whole number, if we say yes, then we say that the value of the kth percentile is midway between the Lth value and the next value in the sorted set of data. Then you would find percentile of K by adding the Lth value and the next value and dividing the total by 2. Now, if it is not a whole number, then you would change L by rounding it up to the next larger whole number. And then we would say that the value of the percentile of K is the Lth value counting from the lowest. So let's go back and let's take a look at an example here. So here's an example. It says, example 4, we're converting a percentile to a data value. And where we're going to refer to the 50 sorted Space Mountain wait times in the previous example, and then use the procedure in figure 3.7 to find the value of the 25th percentile. So the first thing we're going to do is the following. We can proceed to compute the value of the locator L. In this computation, we use K, which is equal to 25, because we are attempting to find the value of the 25th percentile. And we use N equals 50 because there's a total of 50 data values. Okay, so now what we're going to do is use the value of L when using that formula. Well, we know that the value of K, okay, from our problem, the 25th percentile is 25. And then we're dividing it by 100, and then we're multiplying it by the value of N, and we know that N is 50. So if we use our calculator to find that result, we take 25 and then divide that by 100, and then we're going to multiply that by 50, and that gives us 12.5. Now 12.5, if you notice here, it's not a whole number. So now we need to go back to here where it says change L by rounding it up to the next larger whole number. So since L is 12.5 is not a whole number, we proceed to the next lower box in the figure 3.7 where we can change L by rounding it up to 12.5 to the next larger whole number, which is 13. Now, from the bottom box, we see that the value of the 25th percentile is the 13 value counting from the lowest. Okay, so that means we're going to do the following. Up here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So therefore, there's our value at 13. You can see what number that we get. So in the table, the 13th value is 25. That is, the percentile of 25, or the 25th percentile is equal to 25 minutes. So roughly speaking, about 25% of the wait times are less than 25 minutes. And therefore, 75% of the wait times are more than 25 minutes.